lecture series. Dr. Ki Moon from the Department of Mechanical Engineering. Dr. Moon received his Ph.D. from the University of Illinois in Chicago, and then had a faculty position at the Michigan Technological University, and came to SDSU in 2005.
That's right.
And he's professor in the Department of Mechanical Engineering here. Also deputy director of the National Science Foundation.
I was.
You were? Oh, okay. I must have looked at the wrong. You actually sent me a blurb, so I kind of
then
put
I
it
took
together.
the old one then.
Yes. So he was deputy director of the National Science Foundation Engineering Research Center for Sensory Motor Neural Engineering. Whew, that's long. CSNE, that's short. He received in 2010 the SDSU Top 25 Award, and in 2011 the San Diego State University Monty Award. And he does fascinating work on brain-computer interfaces, which he will talk about now. Thanks a lot.
Thank you, Dr. Mueller, and thank you for the opportunity. And well, this is the first time anyway I give any lecture in non-engineering.
Yeah.
So, but
that's what CCN is supposed to be all about.
That's right. But still science, human science, right?
Yeah.
And so I know you are, the really fascinating work. Understanding the human behavior is really, really difficult. I've been, knowing my wife since age of 18, but still I find a new. Still don't understand. But what I'm trying to say today is maybe a very small part of the human understanding, and very, very quantitative way to peek through the brain, and especially using the machine or the device. Of course, there are motivation of doing that, and as your major will be that you get from the survey, from the interview, or recently you use MRI, right? And so that you understand the brain. But can we have the kind of talk to the brain? And can we actually exchange the information or the data in real time? What would happen? So that's the kind of area we're getting into. Of course, we'll talk about some issue in ethics if we do that. But we are moving too quick to the area that we need help of the human brain, the intelligence. And so we'll get into the area. As you well know, this is the human brain. And this is the about, they say 3 pound, about a grapefruit, this size organ. A lot of them is water, fat, and protein. But just mixing up the proteins and the waters and fat, that wouldn't make the brain, right? There are a lot more than that, because it has the folds, and there are a lot of things going on. And especially, there are neurons, and it is organic. They interact with each other, and that takes a lot of things. Not only the control of the muscles, understanding the organs, operations, handling the memories, emotions, but also it performs the computation like the computer. So the approach that I do as an engineer, consider brain is a computer. Actually, it is a computer, and it is not, the quad, the CPU that you buy, i5, i7. It has the billions of the neurons. They do the simultaneous parallel processing. So it is supercomputer, very small, and it is organic. It forms a CPU by itself. based on the need. So we are handling that, and the scientists, and they found that like the computer CPU, and the brain takes that, the functions, and based on the area, and for example, frontal area handles the behavioral control, emotions, problem solving, and planning. And from some kind of accidents that someone got the damage on the frontal area, found that there is a change in the behavioral control or emotions, or that was the area that handled. But now like Dr. Mueller, and a lot of work, and now the scientists they are making kind of a detailed map about the functions of each area of the brain. And biology says that there are two kinds of the brain cells in brain. One is the glia, and like glue, the materials, and 90% of it, but we do not know much about that. But there are the neurons that I like to talk about. There are 100 billions of the neurons in the human brain, and that performs the brain work. So a lot of that will be related to the neuron. It is compact, and it has the cell body, dendrites, and axons, and it has a synaptic junction with other neurons, and work together. It is almost the same as the CPU that the engineers and design and make. For example, the CPU you buy, like the Pentium or i5 or i7, you'll find that multi-million transistors, and they are interconnected together. So it is almost like the neurons are connected through the synaptic connection through the other neurons. So the approach that we do will be almost like the picking through the computer. Like the CPU, when you make the transistor, so this is like the transistor, and then you have it generates the electric signal. So through the electric signal, in case of computer, the electric signal you use is usually 0 volt or 5 volt. So 5 is 1, 0 is 0, or you say yes or no, 1 or 0, we call binary. Okay? So there is a lot of the binary, the communication. The number of the binary communication we say in computer, we call speed of the CPU. So you have 1 megahertz, 10 megahertz, gigahertz, right? That's the so-called clock speed. Like the human brain, the CPU of the computer, and make a connection with the other the transistor, and that forms the different functions. For example, when you buy the flash memory, it has just a bunch of the transistors. They are connected with certain forms, and then it memorizes the information. So you can take it, or you can put it, retrieve it, save it, and then, or you can have a more complicated, the functions of the CPU do the computation, or sometimes even more complex, the operation, such as artificial intelligence. But the difference between this human, the made CPU, and the brain would be that one is fixed. For example, when you set the given number of the synaptic junctions or connections is fixed. So that gives the permanent, fixed the capability of that CPU. But human is not. Human is organic, and then you develop the junctions, or you destroy the junctions, depend upon the need or depend upon the disease. So for example, and in around the 6 the years of age, a lot of brain activities with the learning process, make a lot of synaptic junctions, and you see the really busy, the interaction between the neurons. And later, the busy traffic will be less and less and less. And the biology identifies that each individual neuron looks like that. Okay? So there is a nucleus or cell body, and axon, and then also dendrites. And the dendrites touch with the other neurons, and they make synaptic junction. And the information here will send through the next the neuron, not just the one or the multiple one, and they form a network. So they make a neural network, and they perform certain functions. And from the basic learning process, memorizing process, and then also other types of very complex thinking process. And like the computer, when you have a CPU make the computation and make comments. For example, in our lab, we have so many the computers. A lot of them we use it for the control purpose. So the CPU is a controller, and it receives the information from the sensors. We have a camera. Camera sends the vision information. We have a microphone. It gives that sound information. We have many sensors, and then computer or the CPU receive that. And it changes all of those informations into an array of voltage change. So, for example, originally it was the analog. For example, the sound, what we are here, was analog, meaning that it's moving pretty much continuously, but we changed to the language or the signal that the computer understands. That's the binary signal. So all we changed to digital 0 to 1, and the 0 to 1 will be changed to the voltage, 0 volt and 5 volt. So in CPU, just the 0 volt and 5 volt will move. Same way, pretty much done in the brain. They send electrochemical signal. They sense the electrochemical signal like the computer that I have in the lab. So after certain computation, my computer send the output, move the robotic arm to right. Then it will send the commands. The commands will be changed to the the current or the voltage to move the motor, and the motor will move the certain, the distance with the feedback from the sensors, either muscles or eye coordinations, and then we'll have a continuous control so that we control a robot. So that's what it is. We found that brain does, of course, only small area of its wide spectrum of the capability. It controls the motion of the body through controlling the lot of muscle fibers. And those muscle fibers will be connected to the nerve, and actually electrochemical signal will be sent, like the electric wire, but through the nerve, and then muscle will receive the electrical signal and will contract, and basically we move the body. The similar way, and a lot of the organs and will send the sensory information to the brain, and will have the the computation in the brain based on its logic, and either perform many things, sometimes voluntarily, sometimes involuntarily. So we want to peek through it, and the most basic signal you want to touch is this. That's the action potential. Actually, this is electrical pulse. So it is a binary spike, about 100 millivolt, and actually the neuron and generate the pulse, and we want to tap this one and see at what situation the specific neuron will generate this signal, and we want to tap it. Since it is electrical signal, now it is what area of the engineers, because we are good to they handle the electrical signal. We are good to change the electrical signal into the programming language. We are good to make the program to compute, and we are good to change to something else. So this is the one that so what we understand the human or the brain is just nothing but what? Pulse. But as you know, brain is so complicated, and there are the tons of the information coming out from the brain. But if there are some issues in that pipeline of those electrical signals, then there is disease or disorders. And some of the disorders we have is the dementia. Is there anyone who they study the dementia? No one? Okay, so for example, the dementia is that this is the healthy, the normal brain, and this is the the brain of the patients with the severe dementia, and you see that it got the shrink, and then not only that, it is very now it's not soft. Originally, the tissue is very, very soft, but it is now pretty much hard. And because of that, it loses the information in the cortex, and that way the patients lose the memory, and then or change the the behaviors, have the abnormal the emotions, and the many things happens because of that. How to treat that? Of course, there are many ways of that. The one thing I know is that walk a lot and eat a lot of cooked tomatoes, right? That's the only thing I know. But wine. But I cannot drink the alcohol, and I have an allergy on that, so that doesn't work. But anyway, so there are some way to treat that. But can an engineer help this case? Actually, there are some of the research going on in some of the university that when we have the patients who has the progress of dementia, try to save some of the basic memory into not the brain cell, into it. Chips. And then connect it together so that the patients at least have what? Basic information about his or her identity or some basic things. There is some ongoing research that, in that aspect too, but very, very difficult to do, obviously, and it's not my area either. But there are some a little bit easier one than the dementia. So that one of them is a stroke. Okay? So you know what is a stroke? And usually the blood clot that blocks the passage. And then some areas of the brain cells now has what? No supply of oxygens and will die. And we have a damage of that. So here is that the area shows that the dead cells in the brain because of the stroke. And in that case, we usually know and what would be the cause and where is the area of the problems and what is the consequence too. Many survive from the stroke, and then there are long and painful rehab process. You know that, right? Long and painful. The reason why it is long